this video we are going to discuss about Thevenin's theorem. But in this case we are going to see when there is dependent source. In the previous video we see when there is no dependent source. In this case, when there is dependent source, we already know dependent source can be either with current source or voltage source. We see now, if for Thevenin's theorem we need to find VTH and RTH, as we see these two terms. Now to find the RTH, first of all dependent source, all the dependent source we have to independent source, we have to off them independent source. Second, introduce voltage source or current source I0 or V0 in the node terminal. To facilitate the thing, we always introduce I0 equal 1 ampere or V0 equal 1 volt to facilitate the calculation. Now let's say, for example, we are going to use this two way. We'll off all the independent source and we'll introduce, if we introduce I0 as equal I 1 ampere, means that RTH means that we are going to find V0. Now RTH is going to be equal V0 multiplied by I0. Thevenin equal the V0 that we will calculate multiplied by I0 that we already assume equal 1 ampere. But if we introduce V0 equal 1, means that we are going to calculate I0. After that we will have the Thevenin's resistor as V0 divided by I0 from Ohm's law. Now let's see one example so that we can understand. Let's say, for example, we have this one. In this one we have what? We have a dependent source. Since we have dependent source, to determine RTH or Thevenin's, we are going to off the independent source. This one is independent. Since this current source, to off it we will open. The second, introduce a voltage or current source. I will introduce a voltage or current source here. So my circuit will become like this one. I'll have this one, okay. Current source. I will introduce the voltage source here, plus minus V0 equal 1, plus minus V0 equal 1 volt. We assume V0 equal 1 volt as we said. Now if we assume V0 equal 1 volt, we will determine I0. I0 is the current distributed by V0. Now I have this one is independent source is removed since it is current source. I will have 4 ampere here, I will have 2 ampere here, I will have 6 and have 2. Now here I have minus plus 2 Vx. I have my Vx here. I want to determine I0 so that I can determine RTH. Use any method that we learn. Let me use mesh analysis. I1, I2, I3. So now you can determine this I1, the equation from here, and the equation from here, and the equation from here. I'm not going to repeat the mesh analysis because I will already discuss a full video how to do use mesh analysis. So if you have to watch the previous video with the mesh analysis and come and solve this one. Now if we would determine the equation from I1, I2 and I3, you will see I3 is opposite of I1, of I0. So I0 is going to be minus I3 because they are opposite in direction. Now if I found I0, I want to find VT hash, RT hash. RT hash is going to be equal V0. I already fixed one. I0, I0, the value of I0 that you already calculate from here. You put in place here. Now I0 here, the value this one. This one come from the V0. I already fixed, just to fix one, so that we will determine RT hash. Someone else can I can assume here as a current source. As a current source. So if I assume a current source I0 equal 1 ampere, so I have to find V0. V0, the voltage. Since it is I0, I have to find V0. You use the different method. So you use the different method that we learned before and use it to determine. Now how to determine VT hash? I already determined VT hash, RT hash. Now how to determine VT hash? To determine VT hash is the same thing as before. You just to bring back your current source, your independent source, and now you have to determine VAB. And VT hash, since there is no current will flow here, since there is no load, it is open. VT hash is this one, the voltage across this resistor. Now you use any method you need. We learn many different methods. Here I can use what? I can use mesh analysis here and here. Anything I want to define the voltage of this one. If I found this current, it's easier for me to determine the voltage of this one. 6 multiplied the current. I can use this source of transformation. We learn source of transformation. Since this current source and this voltage are in series parallel, I can determine them in parallel in series, as we see before. After that, I use mesh analysis. Now, use different methods that we learned before. The important to find this voltage across this 6 resistor. So V, it can be equal 6 multiplied by the current of this one. If I use mesh analysis, it's going to be I3. If I mention this one is I3. Now, if I found VT hash, I found RT hash. Now it's finished. And that my Thevenin circuit is going to be equal. Since there is no load here, so we don't need to put. I just found the RT hash and the VT hash. Yeah, load. We'll remove the load here, but there is no load is there. So now I already found my Thevenin theorem. The thing is that when there is dependent source, we off all the independent source. After that, we introduce either a current source of I0 equal 1 or a voltage source of V0 equal 1. Let's say, for example, in this example, I don't have any independent source. That's good. If there is no independent source, I'm not of any. I just only have this one. To determine the RT hash, I'll just introduce a voltage here. Source V0 equal 1 volt. After that, you determine any, use mesh analysis to determine I0. I introduce V0 equal 1 volt. Now I have to find I0. If I found I0, I directly determine RT hash. Now, if I want to find VT hash, is the voltage across this one, since no current will pass here. So is the voltage across this one. You use mesh analysis again to determine V. When you use mesh analysis, determine V0, you determine the voltage of this one. This one is going to be 4 Vx. Vx is going to be equal 5 multiplied by the current I1, so that you can determine the voltage VT hash. VT hash is going to be equal this 15 multiplied by the current Ohm's law. So if you already found the voltage and the current, so Vt hash, our circuit is going to be Vt hash and RT hash like this one. So we see when the case when there is dependent source and when there is no independent source.